to my channel, Run with Henry. So today we are already at the end of our challenge, right? So we already solved the perfect rectangles. We already solved the how to say the outline rectangles, and the very last one is the diagonal rectangles, right? So I think from the previous two rectangles, you are getting to know better how to implement this that kinds of problems, right? So let's put here. So we have the now we have diagonal rectangle. Okay, let's say your diagonal rectangle it's 3 multiplied by 3. So it's supposed to have something like this. Oops, sorry. Only the diagonals, right? Okay. Okay. So your row, this is your columns, and just saying your row n equals to 3 and your column n equals to 3. Okay, so let's analyze this rectangle first, right? What pattern can you see in here? Yeah, how to make, maybe I'll point it out, this one, right? So you have two diagonals. Yeah, if you could see here, it will be a diagonals, right? So the first diagonals, this one, right? So let's just focus on the first diagonals, right? So what pattern can you see in the very first diagonals? Do you see the patterns? This pattern is quite pretty straightforward, right? So if you could see here, if your row is equal to 0 and your columns equal to 0, you will print X. I mark with the green colors, right? So whenever your row equals to 2 and your columns equals to 2, you print X. That's right, right? So your very last one, whenever your row equals to 2 and your columns equals to 2, so you will print X. Right? You got the idea? So maybe I'll take it out. Okay, I'll take it out here. I make maybe the rectangles with, for the better efficiency, I put 5 multiplied by 5, 3, 4, 5. Okay, I think that's a 5 multiplied by 5. Okay. Okay. So the very first condition is that the very first conditions, whenever your row equals to columns, you need to print X. Okay. And now moving forward to the to the second diagonals. These diagonals. Oh, it's too messy, yeah. So let me write as the maybe green colors. Just put the purple. These diagonals. Okay. These diagonals. How to create these diagonals? Do you know how? maybe it will take some time for you, but you need to find out like you need to do analyze. Yeah, you need to analyze what pattern may occur through these iterations. Okay, so the idea is like this. Okay, so if you see in here, this is your columns. So this is your row and this is your columns, right? So whenever, so just say this one is your row, this one is your column. Whenever your row 0 and columns equals to 4, you print X, right? And this one, whenever your row 1 and columns equals to 3, you print X, and so on. Okay, so on. 2, 3, 4. This one is 2, and this one is 1. Okay, and this one is 0. Okay, you got the idea already? What pattern appear in these loopings? If you could see, every time you add, yeah, you see 0 plus 4 is 4, right? 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4, 4 plus 0 is 4. Okay, so you got the patterns already, right? So the condition is when your row, okay, equals to, got the idea? When your row, or maybe we could say our, yeah, maybe we could say our columns, yeah. Whenever our columns equals to equals to column n minus row minus 1. Okay, so let me write here. Whenever your column equals to column n minus row n minus 1. Okay, so you iterate, you vary. So let's try to do the simulations. You start from the row equals to 0, right? So let's see the first one. So your column ends is equals to 5, and your row equals to 0 and equals to 1. So whenever you calculate this one, you got the index of the column when is your very first iteration. So this one is 4, right? So let's try to iterate to the second row. The same, your column n is 5 and your row is equals to 1, and you minus 1 because you're starting the index starting from 0, right? So 5 minus 2 is 3. You see, you print x in index 4, you print x in index 3, and again second one, you have your column n is equal to 5, your row is equals to 0, because you're starting in here right now. Okay, number 2 minus 1, so 5 minus 3, so you got 2, so that's why you print x in the columns 2. Again, 5 minus, your row is now row 3 minus 1, 1. Your column ends is equal to 5, your row is 4, and last one you minus 1, and you got 0. That's why you print, when you are in the 4th row, you print x in the column of 0. Okay, I think that's the idea to analyze the patterns occur in these diagonal rectangles. I hope my explanations could give you a better view how to solve this challenge, right? So in the next video, you're gonna see how to implement in the codes. Okay, so please try to simulate by yourself to better understanding of this topic. Okay, until then, and see you in the next video.